Hi. In this video, I'd like to highlight some new capabilities recently added in Db2 11.5 and how you can exploit machine learning in the database, including being able to do in-database machine learning with models built on enterprise AI platforms like H2O Driverless AI and IBM Cloud Pak for Data. Now, infrastructure is obviously an important part of the AI discussion. For example, IBM Power 9 servers and recently announced Power 10 capabilities have been designed for AI and machine learning workloads. But let's talk data. And as organizations' use of machine learning continues to grow, it's becoming increasingly important to be able to perform training and inferencing where data is generated or where it lives. For model training, Db2 includes a number of stored procedures for building regression, classification, and clustering models with data that resides in the database, as well as the subsequent inferencing or scoring of newer data that comes in. Db2 has also added the ability to create user-defined functions written in Python, which expands on the use of machine learning even further. For example, if you're a data scientist that likes to do your model development work by writing Python code, you can export the trained model out into a binary file that can be loaded into a Db2 Python UDF for in-database scoring. For instance, you could do this model development work in Watson Studio with Watson Machine Learning, which are components of IBM Cloud Pak for Data. Here's a very simple example using the well-known iris flower dataset, where the specific iris species can be predicted based on various measurements from the flower. I should be clear up front, I am not a data scientist, nor do I play one on TV or on YouTube. With what I'm going to be showing you, you can do some pretty cool and complex things, but simple flower identification with only 4 input variables is a little more my speed. So using this iris dataset, I trained a decision tree model in a Jupyter notebook using scikit-learn. And here at the end of my notebook, I export the model that I built out to disk. Moving over to Db2 now, here's the source code for the Python UDF I wrote. You can see that it's really short and simple. I'm basically just loading that exported model in. I call the model's predict method. And then I pass the predicted class, the species name, back to the caller as a string. I needed to pass the species names into the code to do this, so I use the same dump and load method for that. Of course, you can include whatever logic you need in there. You could return the class index instead of a string, or you could return the probability of the prediction, or you could add input validation, whatever you want. So with the code in place, the user-defined function itself needs to be created in Db2 before it can be used. And here's the create SQL statement to do that. You can see that it points to the Python source file. So here, I'll execute that create statement, and you can see that it's successful. I've got a file here with a few test SQL statements in it. They're passing the input values directly in the statement using the values clause. But in practice, you'd likely be calling the function against data in your tables. Or not. An app could be calling the function in real time as data is coming in before it's stored in the database, like this, or as part of batch processing against existing table data. Lots of choice and flexibility here. Again, this is a pretty basic example, where I'm just returning the flower species. A real-world scenario might be looking for fraud as credit card transaction data is fed into the database, or automatically classifying a customer as their information is added into the system. The point is that as a user-defined function, it's all customizable. Some data scientists exclusively code their own models, but others don't. Increasingly, enterprise AI platforms with point-and-click automated capabilities, such as H2O Driverless AI, are used to support machine learning initiatives. For those not familiar with driverless AI, it's a platform for automatic machine learning. It automates some of the most difficult and time-consuming machine learning tasks, such as feature engineering, model validation, model tuning, model selection, and model deployment. It aims to achieve the highest predictive accuracy, comparable to expert data scientists, but in much shorter time, and with a focus on interpretability and helping users understand the predictions made. I'd like to briefly show how easy it is to train a model in driverless AI and then use that model in Db2. By the way, the term driverless doesn't refer to the drivers you might be familiar with in Db2. This term is meant to highlight that you don't need an expert data scientist behind the wheel to get started with machine learning problems. It's a great tool even for novice data scientists, helping democratize machine learning and lower the bar of entry. I start by loading the dataset into Driverless AI, taking a look at the data loaded in to make sure it looks valid, and then finally choosing to start an experiment. I'm using the same iris dataset again, just for illustrative purposes. In practice, though, Driverless AI is built to handle much more complex and large real-world problems, with gigabytes of data and very large numbers of input variables, or features. Here, you can choose the target column that you're trying to predict, which in this case is the species. I'm going to leave the defaults for everything else. And that's it. We can start the experiment. And this sends Driverless AI off evaluating different model types and coming up with different ways of dissecting and combining the data and running through thousands of iterations of this, ultimately ending with an interpretable, trained model. You can see here that the final model is a light GBM model. As part of this process, Driverless AI automatically builds a scoring pipeline for the model, including what they call a Mojo, which is effectively the code and runtime environment for performing real-time scoring with the model. It can be downloaded directly from their GUI here. So I installed all the prerequisite Python packages and dependencies for the Mojo to run within my environment. But from this point on, it's very similar to the example I showed earlier. Here's the Python source code for the UDF I wrote. Again, not very complex. I have the name of the Mojo file that I'm going to load, which is the file I downloaded from the GUI earlier. And I'm loading it in here. Then I set up a data frame that contains the input values passed in. And then we make the call to do the prediction. From there, I find the class or label name, the species type in this example, and pass that back to the caller. And just like before, the UDF itself needs to be created within Db2. And again, just to test it out, here are a few statements that call this new UDF. As I said earlier, I'm no data scientist, nor am I a web designer or a web developer. However, I thought it'd be interesting to create a simple web application that demonstrated this a bit more visually. Really simple, as you can see. Just be happy there are no flashing banners or dancing babies. That would have been the look of choice the last time I created a web page. So the app accepts the 4 flower measurements as inputs. And then you can click here and have it determine the species based on that input. And in this case, the model predicts that the iris species is versicolor, based on the measurements provided. Let's do that one more time. And this time the predicted species is Virginica. The backend for this is a Java servlet that connects to a remote Db2 11.5 database and calls the Python UDF with the data entered by the user. Here's what that backend Java code looks like. And you can see here the code for connecting to the database, along with the call to the UDF and the querying of the results back from that UDF. And this UDF was the one we created earlier that uses the Driverless AI model. I hope that all of this has given you some ideas around how you might be able to leverage these in-database machine learning capabilities with Db2 in your own organization. Thanks for watching.